Yes, sir, we could go. Yeah, hello everyone. Welcome you all for this AIML end-to-end session. So, I'm myself Raja and sir, and we are gonna dive deep into the field of data science, that is AI. So, yeah, sir, over to you. Yeah, so that's the thing. Okay. So,
So,
guys, today, yeah,
yeah,
go ahead,
we are
sir.
starting, guys, data science process overview. So, we'll
Yeah.
go into details and understand the process, data science process, and we'll have an overview. And yeah, let's start.
Yeah, sure. So today we're gonna see data science process. I think we already know about it, but like we're gonna see in-depth kind of thing. Okay. So yeah, we already know. No, data science process is a structured form where the major concept is that we need to convert the raw data to the meaningful information. So we're gonna follow a sequence of steps to get the meaningful insights. Okay. Yeah, I'm very happy and excited. So I think we can move on to the next slide. Okay. So the first thing that we need to do in the data science process is problem formation. Okay, so the problem should be in a manner it should be has some industrial like business understanding and industrial understanding. Okay, so what is the business goal of the problem and how the data science will help to achieve the goal. So these are the two different things that you need to know when you comes under the problem understanding. Okay, then there goes data requirements. Okay, what type of data we need and which source we gonna fall into. As we are mentioning, no, we are suggesting and we are insisting we need to go for a pure form of data, that is a legible data we need to go. So that's a major thing, that is what the data requirements. Finally, performance metrics. Okay, how will the success of project is measured. So this everything comes under problem statement. So I'm just mentioning the textile project, right? So once we are ready with everything, then only we need to proceed with the project. So that's a major thing. So we need to get the approval from the client and what are the things that we can do and what are the things that client expect. So this everything should be in a documented form. So we need to formalize the problem so that only we can have an understanding of what we can do. So this is a major step and a first step in the data science process. Okay. Yes, sir, over to you.
Yeah, so under formulating, like we have to formulate the problem, like we have to understand it, and we have to clearly define the problem like you're trying to solve. That is why we need to develop a problem statement, and it requires approval. You need to first do analysis, and it itself requires a research problem statement. And when you formulate a problem, it requires itself a research. Later you have research, you collect data, and then you do research. But lot of people miss this particular thing. They think, oh, we understand problem, we know what is problem. But no, understanding, formulating the problem deeply is the first fundamental job of a data scientist or any researcher or any problem solver. So you have to understand deeply the problem like nobody else understands. That is why you will be data scientist. Otherwise, why you are there? There is no need to keep a give somebody salary and give somebody work if he has to have a deep understanding of the problem statement, and that itself is a mini project. I will call, when you go and define problem statement, it is a mini project which you have to do on the problem statement. And then it is going to help you business understanding, what are the goals of business, how can data science help achieve those goals, and then data requirements, what type of data is needed. It will come from problem statement. What are the like data sources? So from where you are going to get the source? Is it biased data, or is it normal, a pure data, or a true data, non-biased? It's very clear. You have to use critical thinking. Then performance metrics, that how will the success of project be measured. So you have to make a kind of charter, uh, kind of template where you need to mention all those things, and then you have to formulate the problem.
Yeah. So yeah, that's a nice explanation, sir. So I want to just go for a simple example in order to go for this entire flow. Consider a client is coming to you and he is asking for a chatbot. Okay. The first thing, we need to go for the business understanding. What kind of chatbot they need? Consider they need a chatbot for their website. Okay. Okay, this is the problem statement given to you, and this is what their business goal is, that their clients, their users, okay, actually need to use their chatbot to know about their website. Okay, entire thing. So this is what the business goal given to you. So as a data scientist, what is the business understanding from it? So what is the goal? So we need to create a chatbot for their website, and it should be usable by their users to get the understanding of website. That's the first thing. Okay, guys. So then how we can apply or use our data science skill to achieve this goal? First of all, okay, how, what are the things that we can do? We can create a chatbot by using LLM, and we need to first of all collect the data. We need to have their own data, okay, right, their website data, so everything comes in place, right? So this is what the goal that we can achieve using data science. Now, what is the data requirements here? As I'm mentioning, right, the target problem is just their website. So we can just collect the data from their website, and this is what the source. So now there is no problem in the source. So we have a data ready. Okay. So once it is ready, we can go for a model building and we can create a chatbot. Finally, performance metrics, we can measure by using the success. Okay, once we just deliver the product to the client, and our goal is not ended there. There will be a continuous cycling, okay, feedback loop, everything happens. Once the user of the client uses that, lot of advices, lot of improvements the user gonna ask. You need to keep the chatbot in the two-layer manner. It should be available in the website and also for the phone. Like different feedbacks will be given to you, and you guys need to work on it. So yeah, this is how a problem statement can be. Okay. So I think it is much for the problem statement formulation. I think we can move for the next slide. Okay. So yeah. So the next slide, it is all about data collection, guys. So as I'm mentioning a problem statement, right? So that is very easy. Okay. We just need to scrap the data from their website. Okay. So data collection is a process that we need to collect the data in order to perform some kind of analysis. Okay. So it can include the database data stored in the database, or we need to scrap the website, or need to collect the data through some survey kind of thing, the form kind of thing. You are having Google Forms, right? So that's the thing. So you should find a way how we can collect the data. That's a major thing, guys. Okay. So first of all, we need to identify the source. Source can be anything. The problem statement that I'm explaining is that source is the client website. Okay. We just need to scrap the data. If they have a data, they can just give. So scrapping is also not a problem. We can directly get the data. But most of the time, guys, believe me, most of the time the data is gonna be in a hidden format only. So you guys need to find the data for the problem statement that the business is giving. Okay. So you can use relevant databases where you can fetch the data, and you can use APIs. So whenever consider you are asking to create a weather chatbot, you can go for different APIs that we are having, right? So that's the one thing. And some external sources you can use. But before going for some sources or APIs, you guys need to get an approval from the client side. Okay. After deployment and after everything, doing model training, everything, if a client says no, we doesn't need to use some external source, then there comes a problem. Okay. So that's the reason you guys need to have a proper problem formation. So that's the thing. Okay. Next we go for data acquisition. So once we extract the data from the source, and we need to store the data in a suitable form. So we are explaining, right, today the data is unstructured. Believe me, every data is unstructured. You are seeing a video of us, we are just teaching you guys. So this is unstructured data. It's gonna be frames. Okay, the video is gonna be frames. So how you gonna get the images from it, get the speech from it? So it all gonna be unstructured. So you need to find a suitable way to store this data. Okay. So the next thing is data validation. You need to ensure the quality and consistency of the data collected. Okay, how much quality the data is and how consistent. So for example, if you go for a weather API, so you need to have a well established website which gives us the API for weather prediction, right? So you guys need to have that much confidence to use their API. So you guys need to have this data validation. So it is the data collection is one of the important steps. Yeah. So over to you, sir. Yeah. Yes, sir.
Yeah, so these are the processes, like we have to collect data. So data collection is like you have to gather data, whatever you need for that problem statement. It's very specific. It's not that data you will get your problem statement says X and you collect data for Y. It should not be that. It should be only for X. So this may involve assessing the databases, scraping websites, and collecting data from other surveys like secondary research done, or you have to do your own primary research. You will do own surveys and stuff and collect data. So it can be multiple. It depends on your problem statement and how much time you have. Suppose you have less time, you have to rely on secondary data because primary data will take a lot of time. So you have to understand the nitty-gritties of feasibility of data collection, that from where you will get, and it depends on the timeline also, how fast you have to deliver the project. And then identifying data sources. So what are the which data is relevant, okay, APIs or external sources, as I've mentioned earlier. Then data acquisition. You have to extract data from the sources and store in a suitable format in your own repository or at storage. So, because you have to keep classified folders or whatever storage you are keeping, you have to keep it classified. You have to name it properly, classify it properly, and so that you, when you keep it organized, so what will happen? So when you go and build models and you start doing analysis and pre-processing, you know that which data belongs to which thing, and then accordingly you will use the programming libraries and stuffs to extract that data, or you will put it in Google Cloud or wherever you want to put. So it depends. So you have to keep it organized. Then you have data validation. So ensure the quality, consistency of the collected data. Like you have to understand that in the previous sessions we have discussed that the integrity, the pureness, um, so you have to see that the consistency, whatever data you have. Quality means integrity, consistency. So you need to have that it is not biased, it is very pure form of data. So you have to consider those um, integrity concerns, and you need to have a pure data, it is non-biased, so that it will help us in the further steps.
Yeah, so that's a great explanation, sir. Actually, so yeah, as sir is finally touching that point, right? It is useful in the future. So you guys need to fix the things. You guys need to get a foundation right. So the data collection is like, it's like it's like a base thing. Once if you guys are settled down and done everything for that, then the future is very easy for you guys. Okay, so I think it's great. We can move for the next slide. Okay. Yeah. So next there comes data pre-processing. Guys, this is gonna be like very interesting thing, but like it gonna be no, I will not say it is difficult. It is challenging thing. Okay. You guys need to prepare the data. Okay. So before going for any kind of modeling, you need to give a data in a form that the model can understand. Okay. I will put it in a simple way. So we are having raw vegetables, right? Whether we eat the raw vegetables, no, right? We should be cook somewhat. We should cook. We should add some salt, some kind of chili kind of things, and we need to make the data. Like we need to make a food, so that only we can, in a form of a food, we can eat the vegetable, right? So that's the same thing for the data. We are going for pre-processing. Okay, so it is going to be very interesting. Okay, so so in order to prepare data for analysis, we need to clean it. Okay, removal of null values, duplicate values, and doing some transformations, structuring it, like those things we need to do. And then we need to handle the missing values, outliers, and inconsistency. Okay. First, data cleaning means we need to remove or correct errors and inconsistent missing values. Let's see. Let us consider what is meant by this inconsistent data. Okay, we are having a column, or consider we are having a record. Okay, so in the record we are having some numerical random numbers, right? 1 2 3 4 5, like that we are having a number, and in the middle we are having some name kind of thing, like consider my name Raja. Okay, just look into this data set. What is the first thing that you guys able to understand? Okay, everything is number, but the only thing which is there Raja is string. So you guys need to remove that. So this is what the inconsistency in data. So this is how you need to clean the data. I'm not sticking to this one point. There are multiple points, but this is how, this is what data cleaning means. Okay, then next we are having data transformation, right? So data transformation means we need to convert the data into a suitable form for analysis, such as scaling or encoding on categorical variables. I think once you move on to the practical approach, you guys can able to understand, but I will say in a simple manner. Okay, so data transformation means, like consider we need to predict some kind of value, which cannot be predicted by using the raw data we are having. We need to convert into some form, and from that form we need to create a new form of a data. Okay, consider we are having some sort of we're gonna have a problem statement, like uh, prediction of uh, what to say, the sales. Okay, so that is what's the problem statement we are having, right? So now we are having only price and area. Okay, area of the house. Okay, now the selling price we need to find. We are having the area and its price. So how we can arrive for the selling price? That multiplying the things, area into this price for a acre or for a square feet. Okay, like that we need to go for some kind of transformation. Okay, so it will be a bit tricky, but like if you guys go for a hands-on session, it will be very easier. So once we move on to the new session, like depth, you can go. So as Ad is mentioning, now we are going in a breadth-wise manner, then we will go in a depth-wise manner. Okay, finally we are having feature engineering. It is a form of creating a new feature from existing data in order to improve the model performance. It is purely depends on the problem statement that you are taking. Whenever the problem statement is insisting or asking you to create a new data, new column, new feature kind of thing, you need to go for it. So this everything makes your model works best. I will not say best, in a better manner. So you should not treat your model to do 100%. It should be generalized, right? So you should not make your model to memorize everything, then it becomes overfitting. Don't worry about this technical term. You should not train your model to overfit. Okay, that is memorize. Okay, so that is what all about data pre-processing. Yes sir, over to you sir.
So again, the we need to focus on the data cleaning part, and then we have to data cleaning consists of removal of inconsistent errors, correcting the errors, and missing values. So we have to do that, and sometimes we have to replace the missing values with some constant values we can replace. Okay, and data transformation, so we convert data into suitable format for analysis so that we do good analysis. So we'll see. So what is this data saying? We need to check everything, and then we need to like scaling and encoding, and we need to encode and understand that we have to make it so that machine understands it. So that is what is called data transformation. So we are not going to give values which machine doesn't understand. So we have to keep considering the programming aspect of it, so that the how machine will understand. So machine will understand based on the libraries and the format and the principles which are there in the programming. So you have to understand that. So if you are not encoding categorical variables, so what will happen? You will encounter errors. So that you will learn once we build the model. You will have practical application of this. But here you need to understand that data transformation is this. So you need to be very simple here. Don't think about future. Just right now focus and absorb this much of knowledge so that when we go for application, so you know what is data transformation, what is data cleaning. And then third step is feature engineering, where you have to create new features and from the existing data to improve model performance. So it is an application part. Here you need to understand and remember that there is something called feature engineering, there is something called data transformation, there is something called data cleaning, so that it is not a magic when we go for application. So you understand that, yeah, the concept I know, but then when you apply it, we will apply. So when you will do final project, so you will understand what it means actually. Here you need to absorb the definition and the explanation which we are giving.
Yeah, so that's the thing. That's great. So I think it's enough for this data pre-processing. So you guys need to have a theoretical understanding of what we're gonna do. Okay. Next. Okay, exploratory data analysis. So guys, this is where we will be getting magic from the data. So I think Sarah also will mention these things because like we're gonna get something like in a visual form, how the data gonna look in a visualized form. So that is what exploratory data analysis. So in this, when we explore the data, we gonna gain some insight and understanding of its in-depth characteristics. Okay, like how the data looks, whether it is skewed, it is positively skewed, negatively skewed. Don't worry about the technical terms, guys. We are here to go in depth on it. Okay, so just understand the things like whether the data is clumsy, whether the data is distributed somewhere, or whether the data is like normally distributed, linearly distributed, like that. So we can get a perfect understanding when we do this exploratory data analysis. Okay, so like why we are doing this, so we get a visualization, so in order to understand the data and identify the patterns and trends of the data so that we can proceed further. Okay, first of all, we are having univariant analysis, means each individual variable we are gonna get each individual feature and we're gonna uh, check it how it looks like. For that we use histogram and then box plot. Don't worry about it, I think we're gonna have a like separate sessions for these things. Okay, so histograms and box plot, it is used for univariant analysis, means single feature. Okay, so consider we gonna predict the heart disease of a patient and we are having the features like cholesterol level, blood sugar level, what is the age and what is the gender, like that we are having. So each thing we are having, no, each features like cholesterol level, blood sugar level, like that. So each feature we are getting a single feature and we're gonna make an analysis, then it is called as univariate. Next, what is a bivariate? Simple thing, right? When we gonna find the relationship between two different variables, then it is called as a bivariate. For that, we are having different terms. Like here, we are having scatter plot and correlation matrix. So in the example, consider we're gonna take blood sugar level and then cholesterol level in order to find the whether the person is having heart disease or not. Okay, that is what the bivariant analysis means. Okay, finally we are having multivariant analysis, that is meant by examining the relationship between multiple variables, where we will be having PCA, principal component analysis. It is one of the greatest approach where we will be reducing the dimension to view the 8D, 9D, 10D, 10 dimension. Like consider any dimension to a dimension that you require, like 2 dimension, we can bring it down. So that is what the power of this PCA, principal component analysis. And then cluster analysis, so we can create a cluster kind of thing and we can uh, find the relationship between the variables in a multi-variant analysis. Okay, so here consider like we are having blood sugar level, cholesterol level, gender, age, everything, and then we will be having the target value whether the person is having heart disease or not. Okay, so yeah, this is all about EDA. I will say it is a magic and it is a visual kind of thing where we're gonna get a powerful insight or a stunning insight about the data. Once you do EDA, I'm pretty sure you guys have a better and great knowledge of what is the data. So there is also one of the important, very important thing, very important stage that we are having in the data science process. Yes, sir. Over to you.
Yeah, so let us understand the term exploratory data analysis. So, explore, let's split the word exploratory into two syllables. So, exploratory. So, when you when you have to explore data here. So how you explore things? Suppose you are visiting a place, Mount Everest. So, or you're going somewhere. So you explore it. Huh? You see how is the market, what are the best places, how, what is the culture, what kind of language they speak, right? All those things. By the way, that's also data. You have to collect that. You have to get the videos, pictures, you have to talk to people. That's itself data. So exploring data analysis. So here we'll be doing exploration of data analysis here. So uni means one, univariate. Variate means variable. It talks about variable. So again, if you see univariate, again two syllables. Uni means single, variant means variable analysis. So single variable analysis you do with histogram and box plots. So histogram and box plot you have seen in Excel. So histogram is which has historical data. It will go up and down and stuff as per the data. And box plots will be the boxes on the plot. So simple. So you can visualize it. Okay. So once we do it, so you will get gist of it. Then we have bivariate analysis. Bi means two. Bi means two, variate means variable analysis. So here there is two variables where will be in we have to explore the relationship between them. So we use scatter plot because we can't use histogram because that will give us univariate results. So that's why they have bivariate to for two kind of variables to compare and do correlation metrics for two. You can't do correlation on one variable. So that is why we need bivariate. Okay. So bi means two, variate means variable. So then we go to multivariate. Now you understand, you can guess. Multi means multiple, and variate means variable analysis, wherein we use PCA and cluster analysis. So it is more than two. We examine the relationship between multiple, more than two. Here, multiple can be two variables also in general English and stuff. But here you need to be very clear. It is more than two because bivariate is for two. So multi is more than two. So very precise. Huh? So this is how we will use these principles to explore the data. It is very critical, guys. So each step, whatever we are going to learn in data science and AIML is very critical. These are fundamental things which you have to absorb deeply so that we are always ahead.
Yeah, actually, like that's a great understanding. Like that's a great explanation, sir. So as sir is mentioning, right? So every steps, each and every steps that we're gonna explain here is gonna be like completely important step. You doesn't need to miss any step. Like if you miss the problem formation, then you cannot proceed further. If you miss the data collection, then it will impact the final result that you're gonna get. Okay, and this exploratory data analysis is gonna give a proper understanding of a data. Okay, so and then the middle layer, like yes, we are having data pre-processing, right? If it doesn't do that, we doesn't get the data which we can feed to the model so that it can digest. Okay, so yeah, that's the thing. Okay, so I think we can move on to the next slide. Wait a minute. Yeah. So yeah, next is feature engineering, guys. So I think we have seen a gist about it. So it is like we are creating a new form of feature from the existing data in order to improve the performance of our model. So this involves transformation or combination of variables to capture some additional information, right? So first of all, feature extraction. How we do? We will derive new features from the existing ones, such as combining variables or creating ratios, kind of. Okay. So whenever we go for some kind of like consider this thing. Okay. So we need to find the performance of the machine. Okay, that was a problem statement, and we are given voltage and current. Okay, and we are finding the performance of the machine. That is some value you just consider. Okay, Now, in order to improve the performance, I'm gonna include one more variable called as power. Okay, how I can include that? We are having voltage and current. What is the formula for power? I'm not asking like uh, you guys need to know that, but like this is how feature extraction occurs. The new variables occurs. That is, the value of power is V into I. That is voltage into current. We are having voltage and we are having current. So just multiply that and we will get a new feature called as power. Now if we go for that, we will get somewhat better accuracy when compared to the previous, because now we are having three features. Okay, so this is what the feature extraction, okay, feature engineering is. Next we are having feature selection. Okay, we need to identify the most relevant feature for our model and we need to discard the irrelevant one. Okay, consider this problem itself. We are having current, voltage, like sorry, current, and then we are having something called as voltage, and we are having power. We have derived power and we're gonna find the efficiency of emission. Now you guys just think, what is the power? It is a combination of voltage and current. So whenever you train your model, why you need voltage and current? Already power is there, right? It is a combination of both voltage and current, right? So you just remove that irrelevant data. That is, you remove the voltage and current. Okay. Now you just consider the power, and then it's gonna give what is the efficiency of the machine. Okay. This is how you can uh, uh, find or select the feature. Okay, I'm just telling in a layman manner, guys. Don't think about it is a proper thing, but like I'm just explaining in a layman manner that you guys can understand. Okay, next, feature scaling. You need to normalize or standardize the features to improve the model performance. For this I have a very good example. Okay, consider, okay, we gonna find the health of a person, whether the person is normal, abnormal, or is having somewhat medium kind of health. Okay, we are having two different columns. Okay, first column is the age column. Okay, where we will be having age from 18 years, 1 8. Okay, 18, I think I'm pronouncing it right, I think so. So 18 to like 60. Okay, 60. Okay, 60. So this is what the range that we are having in the age column. Okay, and we are having some other column like water consumption by the human. Okay, where we will be having 1 liter to 5 liter, 1 2 3, and then we are having 5. Consider these two columns. We are having one column, we are having two digit numbers, and another column we are having one digit number. As a human psychology, you just think of which column is of more priority. Two digit number, right? It has more priority as a vision of human. Okay, we will consider it more priority. Similarly, model will think the column age column is a more priority because it has a two digit value, whereas the liter that human consider for the water consumption is just one digit. So what the model will think means this one digit column, that is water consumption by the human, is of less important when compared to the age column. So it will consider only age. So what you guys need to do means you need to go for standardizing these two columns. You need to bring up all the values within the columns into some range, like -1 to 1 or 0 to 1 or something like 100 to -100 to 100, some range. So you need to bring up everything to a proper range. Okay, so that is what feature scaling means, guys. Okay, so yeah, sir, over to you.
Yeah, so feature extraction again, we have to drive new features from the existing ones. So you will better understand when we apply, when we do project. But here you absorb this, and such combination of variables we create or creating ratios. So that we extract, what we do is we extract the features, okay, and then what we do is we create new from the existing one. That is what is feature extraction. Then we have feature selection. Feature selection is identifying most relevant features for your model. You have to understand the model properly so that you can select the right feature. That is very important. And discard the irrelevant ones which are not required. Okay. Then it would require a lot of some iteration because you have to see which feature will be. And then we have feature scaling. So normalizing, standardizing feature to improve model performance. Standardization is like if you see feature scaling, so you bring features into one scale. So that is a process of uh, standardization. So again, here the word comes standardization. It is a statistical this thing. We have to use stat here. So standardization, we have to standardize using normalization and standardization so that we balance and we bring it to one scale, like one scale, so that we can have better understanding of the features. Yes.
Yeah, actually, like that's a great explanation. Like because like we need to have a every feature in the same script, so that only as a human we also have some bias, you know. So we need to treat the model. We should build a model in a generalized manner. So I think uh, as Sarah is mentioning, you know, each and every step is very important. Each and every step has some unique quality and unique importance. Okay, as you guys see, first step is like problem definition. That has some kind of unique thing that you guys need to definitely have. And then data collection, and we have seen data pre-processing. Previously we have seen something called as EDA, exploratory data analysis. It also has some specific thing to do, some kind of a visual kind of thing that we can get. Okay, and now we are having something called as feature engineering. As Sarah is mentioning, everything should be aligned in a manner that it is properly aligned so that we can train the model further. Okay, so yeah, so that is what the thing. Okay, so yeah guys, we will see in the next session. Thank you guys, thank you.